Hello, everyone. Thank you so much for joining us. Thank you for joining Duke Science and Society for the latest installment of our coronavirus conversations. My name, of course, if you've been with us, is Tim McDermott. I am the event manager at Duke Science and Society. I hope everyone is safe and well right now. Um, Thank you for joining us. Just a few housekeeping notes before I hand it over today to our moderator, Sarah Rispin-Sedlak. The chat is open, and we would love to answer your questions and pass them on to our expert panelists. If you want to send those to Timothy McDermott or Ben Shepard, we will pass them to Sarah. We got a number of your questions ahead of time. We're very grateful for those, and we look forward to addressing as many of those as we can get to. Just a quick note, if we experience any technical difficulties and you lose connection to the meeting, it's not a problem. You can just go right back onto your email and click the link that I sent you, and you should be able to join right back up. And just please be patient with us if anything should go down. The last thing is, if you are just joining us for the first time, I want to encourage you to head over to our YouTube page. Duke Science and Society is on YouTube. We have all the conversations posted there, and we would love for you to take a look at those and share those, as we've had so many experts from around the country join us to talk about important topics in these troubling times. The other thing you can do over there at our website, you can head to scipaul.org, read the work that Sarah and her team are doing on science policy right now, our master's program, where Sarah and our faculty and students are dealing with these questions on a daily basis, before the pandemic, during the pandemic, after the pandemic, addressing these and trying to make sure we're spreading good information and make sure that you are getting the information you need so that you feel safe and you feel secure. Okay, with that out of the way, let's meet our moderator today, Sarah Rispin-Sedlak. Let me unmute Sarah. There we go. Sarah Rispin-Sedlak is, as I said, an instructor here at SNS and the scipaul.org lead for energy policy, fitting for today's topic, obviously. Sarah Rispin-Sedlak gained extensive experience in administrative and environmental litigating in front of federal and state courts, state utility commissions, and participating in the regulatory comment process on both the state and federal level. So she's well versed in these issues. She received her JD from U Chicago Law School, where she was on the board of the law review. We are very lucky to have her at Duke Science and Society, and we're incredibly happy to have her leading our conversation today. So Sarah, please take it away.
Hello, everybody, and welcome. Thank you for joining us today. The impetus behind today's webinar and panel discussion is to take a look at what's happening in the electric power sector as a result of the coronavirus pandemic. We are all highly dependent on it at the moment. We would not be having this Zoom webinar without it. We would not be able to conduct our lives virtually without electric power. Some of us take for granted that it is going to continue to come out of the wall, but at this time, and with the strictures that businesses of all sorts are facing in terms of keeping their workforce on site and healthy, in terms of looking forward, in terms of how their plans are being impacted by the economy and changes in the economy, it's more important than ever that we understand what exactly is going on. So we are fortunate enough to have to be joined today by three people who can speak very directly to how the electric power sector is being affected. First, we'll have Brian Walsh, who is a vice president at Duke Energy, which is one of the largest, if not the largest, investor-owned utilities in the country. It covers Duke's area in North Carolina and well beyond into the Midwest. Brian's unit provides engineering services, analysis, and support for Duke's coal-fired, gas-fired, and regulated renewables fleet. Our second panelist is Mike Smith, who is the Senior Vice President for Distributed Energy at Constellation Energy. He is a Duke Law alum, and he he works in Constellation's distributed energy business, which originates, develops, owns, operates, and maintains customer-sited generation and energy efficiency solutions for Constellation's customers. So they will have been affected in a pretty specific and very different way than the part of Duke Energy's fleet that Brian deals with. And finally, we have Jennifer Chen, who is an energy attorney and now a senior counsel for federal energy policy at Duke's Nicholas Institute for Environmental Policy Solutions. Here, she focuses on electricity and infrastructure policy design to account for newer resources and technologies such as renewable energy, electricity storage, advanced transmission technologies, and demand-side resources, and the very complicated and important decisions that are being made to bring all of those onto the grid now as we go through our energy transition. I'm going to ask each of them to speak to how, from their viewpoint, the electric power sector has been affected by the COVID-19 pandemic. They'll each speak for about 5 to 10 minutes. And after that, we'll start to address questions that you as the audience have, both questions that you submitted prior to today's webinar and questions that you can submit as it goes on. So thank you, Brian.
Yeah, well, thank you, Sarah. And I would like to thank Duke University and Duke Energy for letting me join you today. So these are unprecedented times. I tell my kids, you're living through history, and these are unprecedented for the regulated utility industry also. You know, we have emergency preparedness plans that are typically geared towards storm response. You see a hurricane coming, you know what minimum staffing you need, and you know you got to weather the storm, so to speak. And then after about a week, while there may be some cleanup, things start returning back to normal. But we all know now that there's going to be a new normal for our society, and we're living through this pandemic transition period right now. And so we at Duke Energy had to adjust. You know, we essentially had to create a pandemic plan for our department and for our sites. And one of the things that really became that driving North Star as you created the pandemic plan was to really look at how do you ensure your personnel on site, that they're safe? How do you ensure your environmental obligations are maintained continuously? How do you maintain essential operations and services with no disruption to our customers? And how do you work to limit the pandemic spread to our employees, our contractors, because many of these plants have contract partners that come on site, and also our customers. And so what we did at Duke was really look at our staffing levels and our work that we were doing. In pre-March of this year, you would have what I would call normal staffing, and you'd have your normal work management process in which you prioritize work and you get to things based on a regular priority. You have people showing up to the offices and to the sites just as normal. Well, what we bumped into when this pandemic happened is we immediately said, how many employees would not be negatively impacted if they were to work remotely? They have the technology, they have the tools. You know, a lot of times you can have engineers that can do data analysis through just looking at files, having a Microsoft Teams meeting. They can even do remote troubleshooting. We've had folks walk around the site with an iPad and be able to show a piece of equipment back to someone so we can do remote troubleshooting. So for those folks that could work remotely, we immediately in mid-March sent them home, and that ended up being a significant portion of the fossil hydro department's workforce. We had about 1/4 to 1/3 of our workforce, but then you have the other portion of the workforce that has to show up day in, day out to a site. And we started looking at the type of work that they were doing. Is it something that was essential that we needed to do? Or was it something that could be deferred? Did we need to bring a contractor in, maybe from a different location, that could introduce, you know, a visitor that could be potentially carrying the virus? We started looking at all of these things. Corporately, we stood up what I'll call an incident support team. And it really took our environmental health and safety department to create some common platforms for all the business units within Duke. to come up with certain things to help us navigate this. One example I give is that we created a visitor policy questionnaire where we would ask folks, have you traveled internationally in the last 14 days? Have you been exposed to anyone who either has tested positive for COVID? Are you experiencing any symptoms? Depending upon the answer that folks had to these questions, we might deny them access to the site. So that was one of the things we did. We also established a COVID case management team. So anytime we had a situation in which an employee perhaps felt ill, held themselves out of work, it immediately got us to thinking, who else have they been in contact with? What might we need to do to check those folks and also do some additional cleaning and disinfection in the areas where they had been working? We created some cleaning and disinfection guidelines. We also, at any of our plants, you have a general workforce and then you have the operations force at the plants. Operators are typically highly skilled and very familiar with the plant itself. What we immediately had to begin doing was restricting access to the control room where the operators do most of their work. And we also instituted temperature monitoring so that any person going into the control room, either to interact with the operators or an operator going in to do their work, had to have a temperature that did not exceed 100.4 degrees. And so we had to find thermometers and get them to all of our sites and create a policy rather rapidly in that respect. One of the things, though, that I'm proud to say is that we never got to the point of sequestering operations or folks' site. This was always a fear that you would see an outbreak in any one of your sites. You'd never wanted to lose a site. And so the thought was, before you ever got to that point, would you ever just have a small subset of the minimum staffing for the plant that would come in and work for 2 weeks, and then you change them out after that? Thankfully, we never got to that point, and we never lost a site due to the pandemic. But I'll tell you, it's still something that is, we're not out of the woods yet. We continue to see, even here in North Carolina, I think the 3 highest confirmed case days in North Carolina have happened within the last week. So all of our policies are still fully in effect. Something else we did to limit the amount of outside traffic at our sites, we deferred numerous outages to the fall. If you can, any of you that are familiar with the industry know that springtime is outage season. Essentially, do a tune-up of your plants, do the maintenance you need to so you're ready for the summer run. Well, we got to the point where we deferred anything that we did not think had a material reliability impact for our customers and deferred that to the fall. There are a lot of things we probably should do. We might, have a few nuisance reliability issues because we deferred some of this maintenance, but we thought the risk of that was outweighed the risk if we brought folks on site from out of town that could end up introducing the virus at our locations. So then we got to the point of saying, what are the most important sites that need to have work, or the ones that are at the point in the maintenance cycle where we can't delay any longer? And in order to do that, we did execute some outages, but we tried to be very deliberate in how we plan for that. An example I give is an outage that we're doing in Indiana, in which we created an outage plan that we reviewed with the local health department and the government officials in the area. I think the officials are excited that people will be utilizing their hospitality industry in that area, but they wanted to know that we had good controls in place so we would not present a problem to their local community. So something that we really had to keep in mind. The final 2 comments I make is that this has really spurred a lot of innovation. As many of you are aware, if you go to any store, you can't find hand sanitizer or disinfecting spray. Luckily, because of the scope of Duke, we have a lab at our McGuire nuclear facility in Huntersville that began manufacturing these products. This was really important, so we had them on site for our locations and gave us a way to have something that really we couldn't get out on the open market and was very much essential to the way we needed to be doing business. And finally, I would just comment that as Sarah mentioned, there have been some relaxations on some of the regulations or enforcement thereof inside the industry. EPA was giving some relaxation relative to some of the permitting. We have not taken advantage of that relative to environmental. We have had some certifications, safety certifications. I'd say they're more bookkeeping. Someone is fully able to do a safety activity on our sites, but their training may have just expired during this period, where we have deferred some of that. And OSHA has given us the ability, as long as we make a good faith effort to get them trained before the end of the year, to waive that if they end up going past due on their training. So, Sarah, that's just a high level on some of the things we're doing. Turn it back over to you.
Thank you. Thank you, Brian. We're going to turn it over to Mike now. I'll have several follow-up questions for you, but Mike, could you first, your business is a little different. So could you orient us a bit to how your portion of the business differs from the traditional central utility operations that Brian helps operate, and how that means that your part of the business has been impacted differently?
Yeah, sure, Sarah. Thanks. And thanks to Duke for putting this on and allowing me to join. And thanks for everybody out there who's joining during these truly difficult and challenging times. I also want to specifically thank some of my law school classmates and former and current colleagues that are on this webinar as well. I think the theme of my kind of presentation will be very similar to Brian's, but if you take it down to more the localized level. So first and foremost, when this all began to happen mid-March, we, as a company, Exelon Y, determined that we would be focused on, first and foremost, the health and safety of our people and of our customers across the country, and all assets and all facets of our business. My business is the distributed energy arm for Exelon and Constellation, the competitive business within Exelon. So we have people operating customer-sited power plants. We are a construction business. We build energy efficiency projects. We build solar projects. And we also have a services business where we service these heavy energy consuming assets on people's places of business. So when the 2,200 some odd retail energy employees within Constellation went remote, and many of us can work remote, as you can see behind me. I'm at home now, and I haven't been to an office since March 13th. We have people that simply cannot go remote, not unlike the people that work in the power plants in the central station generation segment of the industry. So we had to determine first and foremost who is essential. How do we get them to the plant that they operate? What are they doing that's essential there to continue the operation of the plant safely for our customers? These are critical infrastructure assets for our customers. For instance, we operate the central steam and chilled water loop in Nashville, Tennessee, that serves 40 some odd businesses and governmental offices throughout the city. That can't go down. So we had to determine which people need to be on site. How do we get them on site safely? How do we keep them on site safely? And fortunately, we have not had to quarantine those people either. But in addition to that, we have these ongoing construction projects in various cities across the country. Pennsylvania, Philadelphia, New York City, all throughout California, building solar projects. Some of these projects were allowed to continue under state law. So we had to put project management resources on these sites in a safe manner to allow these projects to continue, because frankly, these are essential assets for the businesses that are relying upon the benefits that will flow from these projects. But in some states, we were unable to continue work. So for instance, the state of Pennsylvania for a while shut down all construction. We had to demobilize, and the sites were working there. And we had to do that in a safe manner. But then as things have changed over time, rules have changed, we've begun to put people back on site. So what we found in terms of the construction backlog that my business manages, we've basically not missed a beat. We've had some delays here and there. We've had some places where we've had to be innovative and creative in terms of how to continue to work. But we've been able to continue to construct these assets and operate these assets and service these assets for our customers, mostly for the most part through this experience. Where we found slowdown is in the origination of new projects. And that's not because customers are less interested in the benefits of solar, the benefits of energy efficiency, or the benefits of having a third party operate their assets, but simply access to customers and access to decision makers. And even now, just a couple months into this, we're starting to find that customers are getting back to work. And as they get back to work, they start to focus on these things. We just had a board approval meeting on Tuesday of last week, or I guess Wednesday of last week in Western Pennsylvania, where a school district was able to get together virtually and approve our project. And we had to send our head of sales on site with them on Tuesday to sit down with them in a room with PPE and all the normal protections in order to help them kind of work through the presentation. So from a distributed energy standpoint, we're working through this. My view is that long-term distributed energy will continue to be very, very important part of the energy consumption and production portfolio industry. And it remains to be seen how that may even change going forward. Microgrids, self-determination, reduction of costs, and all the things that kind of go along with that, I think will continue. The economic forces that push those types of products and services will continue. The question is, how rapidly can we get back to kind of full deployment of these resources across the country? I'll stop my comments now and look forward to taking questions as we go down the road. Thank you.
And finally, Jenny's going to take a slightly broader view of the situation and talk to us about how we've seen energy policies react until now to the pandemic, which has been mainly, my understanding, is sort of minor tweaks around the edges, and how she thinks that we might, what the forward-looking policies may begin to look like as the industry comes with both the need to engage actively in pandemic and other emergency preparedness measures, and contend with changes in the electricity mix and changes in electricity demand and usage patterns that we should start to see.
Thank you. Thank you for having me and for this invitation, Sarah, and for the kind introduction. I just want to say, coming out of this weekend, I know that there's a lot of grief out there over recent racial violence layered on top of this pandemic. I don't have the space to give that set of issues the discussion that it deserves here, but I can't help but draw upon some of the inspiration from civil rights leaders for the present task at hand, recovering from this pandemic. So in Nelson Mandela's words, may your choices reflect your hopes and not your fears. Along those lines, some of the questions that I'd like to ask today that I don't have the answers to include: how do we emerge from this pandemic to create a productive society that is sustainable, energy secure, while taking into account our health and environment? Are there temporary practices that are worth keeping? What stimulus and recovery policies can help achieve these goals? What practices are worth letting go of as something that we do simply because we've always done it that way? And what lessons can we learn from what other jurisdictions are doing? But first, let me just speak to a little bit of some of the facts and figures of the impact of COVID so far on the energy and transportation sector. So many of us are staying at home, working from home, and that means that travel and commutes are down. Road transport has decreased between 50 and 75% in lockdown areas. Commercial and industrial electricity demand has been down, but residential electricity use has gone up. So if we look at the, if we correct for weather effects, the lockdowns have essentially reduced daily electricity demand by around 15% in several key nations around the world that have lockdown in place. And for the United States, we know that the residential electric demand is up by around 7%, while the demand for C&I customers is down around about 15%. Fossil use has decreased, so global oil demand has halved, and a lot of higher cost fossils are being outcompeted by lower cost renewable energy. Lower operating costs allow renewable energy to operate at near full capacity. However, the additions for new renewable electricity capacity is expected to decline next year by around 13%. And this does reflect the delays in construction activity due to supply chain disruptions, the lockdown, and emerging financing challenges. Fuel and energy prices are down, but as a result, we've seen that, of all of this so far, we've seen that carbon dioxide emissions are down. Global carbon dioxide emissions are expected to decline by 8% to about the levels of 10 years ago. And air pollution is also decreased. And this comes about because a lot of the higher cost resources are actually also more emissions intensive. Traffic accidents are also down because fewer people are driving. And for example, in the state of California, the lockdown has halved traffic collisions and reduced injuries and saved the state around $40 million per year. Some of the second tier implications from this, with a lot of people working from home, energy efficiency could really benefit customers, especially since the residential sector has higher demand now. But the low energy market prices will not necessarily incentivize an uptake in energy efficiency without further policies. In the transportation sector, we know that transportation is a key sector in greenhouse gas emissions. For passenger transport, that sector is responsible for about 40% of oil demand and 15% of global energy-related carbon emissions. A little fun fact I like to share is that the bike sharing in DC has reduced traffic congestion by 4%, which also lowers congestion-related carbon dioxide emissions. We've seen less transit, which is unfortunate, but we've seen an uptick in cycling, which is better for people's health and well-being, as well as for clean air. In New York and Philadelphia, cycling has significantly increased because you've got empty streets now, people don't want to take public transit, and you have better air quality. Bike sales have surged, and bike sharing services have also increased in key urban areas worldwide. But when we think about post-crisis, as people are going back to work, we may see more personal car trips. We've seen this with 9/11, when people sought to reduce their exposure to terrorist attacks in mass transport. So private vehicle use increased there. Fears of COVID has helped increase car sales above last year's levels in Korea in this March and April of this year. And in Beijing, peak hour traffic has been above normal levels as commuters to drive over taking public transport. If we really think that private cars are a solution to some of this for folks that can't access public transport electric vehicles could be a good solution here. Lower carbon options like electric vehicles supported by fuel economy or emission standards or electric vehicle subsidies in certain EU countries. And there we've seen that electric vehicle sales have not declined as much as other car sales in key European Union countries. But with lower oil prices, because of the lower demand, that's not going to incentivize, that's going to work counter to incentivizing electrical adoption. So some of the behaviors and trends that perhaps we'd like to keep or encourage, I think a lot of people would agree that lower carbon dioxide and greenhouse gas emissions more generally is a desirable thing. Cleaner air, which is good. Healthy behavior, like the increase in cycling, is a win-win for health, as well as environment, air quality, and congestion. And just further to that point, less congestion and wasted time in commuting is something I think everyone can agree would be a good thing. So the option to work at home or in the office, having a little bit more flexibility there could help with that. In transportation, we seem to do really well with remote meetings. We're starting to get used to this. Of course, it's always nice to see people in person and have the hallway conversations. But maybe we can think a little bit more, just because since transportation is such a key sector in carbon dioxide emissions, how much do we really need to travel to meetings? And can we decrease some of those? So some of the behavioral changes that, that we'd like to keep could be permanent, but research has shown, in fact, that disruptions can be a catalyst for shifts toward more sustainable transport and use behaviors. But if we want to avoid a return to pre-crisis behaviors, we'd have to look to government policy. So after previous crises, the rebound in emissions has been larger than the initial decline. Just look at past data. Whether this is the case for COVID is contingent on the policies and investment that we come up with in the near future. Clean energy infrastructure and efficiency has been largely driven by government policies historically, and governments now can pursue policies that have already proved successful in the past, such as energy efficiency measures or infrastructure supporting emissions-free technology. We know that promoting clean transport has been a win-win in terms of health, emissions, air quality, as well as local businesses. And I'm going to bring up cycling again because I really love biking as a means of commuting, but it could be encouraged by bike-friendly streets and workplaces. And now, as of late April at least, we know that more than 150 cities have provided dedicated cycling or walking infrastructure to anticipate the post-crisis surge in traffic. There are other means of incentivizing cycling, for example, efficiently pricing congestion or parking. So another interesting fact, drivers searching for parking are responsible for 1/3 of vehicle traffic in urban areas during peak hours, especially with areas with underpriced parking. So here is a key piece that I'd like to put on the table. I know that historically it's always been controversial, but I want to say that eliminating fossil subsidies can encourage energy efficiency and electric vehicle uptake and free up revenue for recovery. Global energy subsidies grew to $5.2 trillion in 2017. That's a significant chunk of the global GDP. These subsidies have artificially kept the price of fossil fuels low, decreasing incentives for energy efficient and clean technology investments. Governments can make energy more affordable to the most vulnerable groups in a more targeted manner. Subsidies disproportionately benefit wealthier populations and that use more of that subsidized fuel. And most subsidies can therefore encourage waste, add to emissions, and strain government budgets. So there are a number of proposals around the globe that are still in the discussion phase on clean recovery. There is a new European Union proposal that calls for investments in clean technologies and value chains for increasing investments in renewable energy, energy storage, hydrogen, and carbon capture and storage technologies. And funds under the plan would be directed toward installing 1 million electric vehicle chargers. The World Bank and the IMF, which are critical lenders to the developing world, have stressed sustainability as they grow in their lending in response to the pandemic. And Chinese leaders have endorsed funding for electric vehicle charging, high-speed rail, and long-distance power transmission that can bring renewable power to cities as well as other technology. What actually happens remains to be seen. These are all, to some extent, controversial. And I know that we're still in a discussion phase in the United States as to our next steps, but it's never too early to think about these big plans. So I'll just stop there, and I look forward to your questions.
Thank you very much, Jenny. So one thing that you touched on there that I think people in our audience are overwhelmingly curious about is how has the pandemic changed demand for electric power right now? What different patterns are we seeing, and what differences in patterns of energy consumption can we expect to see going forward? Because it's becoming more and more apparent that we're not going to experience the V-shaped recovery that we had perhaps hoped for, that we're going to our demand will slowly ramp back up to levels where it had been. but that the economy will be different, and the economy is clearly going to be negatively affected. So can you speak to, I'm opening this up to all of you, how demand has shifted so far, and what you expect demand to look like going forward, and how that might affect your plans?
Yes.
Sure, someone else can go first. I wasn't sure if it was addressed to me, but I think you clarified that. Thank you, Sarah.
Yeah, my comment would be that I'm in general agreement with what Jenny said, that we have seen an increase in residential use, and while our C&I is down. I think one of the biggest things we've noted is that the peaks, the morning and afternoon peaks are being dampened, and the curves during the course of the day, when you look at those load curves, are flatter. We are doing all sorts of modeling, just to the point that you made, Sarah, on like what do we expect the comeback will be, and how much have we been able to learn from Italy and other locations that maybe are a little further ahead of us. I think it really is all remains to be seen. We're hopeful that we start coming back to this to pre-COVID-19 levels, towards the end of this year, beginning of next year, but we fully recognize that some businesses may not survive. So we've done a whole bunch of modeling to try to account for all the cases.
Jenny, before you jump in, can I just ask if with the shaving of peak demand, what sort of resources are there certain resources that you haven't had to call on to supply power so far this spring that you normally would be calling on?
So yes, so we have a dispatch, and we essentially are dispatching off of our variable costs. Fuel is a large driver of that cost. Interestingly, we have seen gas prices rise somewhat, so we still have dispatched some coal, but you have a certain amount of solar, you have a certain amount of hydro in our system that runs. We have nuclear, which is that foundational base load for us. And then after that, it's all on the dispatch curve. And some of our newer plants, many of which are combined cycle natural gas, run at an efficiency level that allows them to have a pretty good amount of runtime.
Jenny, did you want to speak to the changes in demand and how you expect that to approach normal or a new normal?
Yeah, sure. So certainly we want to approach a new normal where we become a society that's highly productive. But productivity doesn't necessarily translate to high electricity demand. Certainly, the answer is going to depend on government policies. If we can incentivize more energy efficiency, for example, now, or, whether people are working from home or not, or demand response, I think that could really help residents save energy. And maybe they would be more interested in demand response programs that historically have not seen a lot of residential uptake. But with more people paying more for electricity at home, they might be more interested in seeing how they can more smartly and efficiently manage their energy use.
Yeah, after the 2008 recession, what we saw was, I was working in the energy efficiency area at the time, and what had been a sort of lukewarm interest became much more avid as school districts and municipalities and commercial real estate companies and factories realized that they could realize needed savings by implementing energy efficiency measures. $200,000 of annual savings to a school district could pay for or make up for losses in their budgets that they experienced as a result of 2008. So can you guys speak to how you expect that we may see a repeat of that pattern? I think it's interesting what Jenny is saying, that the residential sector may become more of a focus, as if we have a new work pattern for, say, the 35% of us who can work from home, who are staying at home for longer periods of time. If you think there might be an appetite for that, and how you would work with people to achieve that. Mike, that might be an area that you can speak to uniquely.
Yeah, we're living it every day. And I like your going back to 2008, because I think that was, one of these large inflection points in the energy industry, as well as the larger economy. Since then, there have been three main drivers of keeping demand flat to declining over time. And it's been changing weather patterns, the driving of energy efficiency and on-site generation into the energy economy. And then the third one is the big wild card is consumer behavior. And during this last 10, 12 years, customers have gotten smarter, both in residential and in commercial space. And not only are they implementing energy efficiency measures, but they're also changing the way they behave in the workplace and in the home. To my eye, that's what the permanent change post-COVID is going to be. Weather patterns are still going to be funky, and they're still going to drive changing electricity use patterns. More and more customers are going to choose, as you suggest, to deploy energy efficiency and on-site generation because it makes economic sense. But we don't yet know the extent to which people are going to return to a traditional working environment and how that's going to impact commuting patterns, use of mass transit, use of electrified mass transit, which is a big thing, and also the demand in our factories and our offices. So we simply don't know that. If I had to guess, I would say that this trend of macro flat to declining load demand will continue, if not accelerate, post-COVID. I mean, it remains to be seen, but I think that's probably where the smart money is. And the question for the energy industry is, how do we adapt our energy networks, our distribution networks, our supply to that changing kind of demand reality? That'll be the big challenge for us.
A related question in terms of how you adapt is resiliency. We've been talking a lot in the electric power sector about resiliency for the last 2 years and I think this is a pandemic wasn't on the table much during FERC's resiliency docket, but here we are. Could Mike and Brian, could you maybe speak a little to how you think your planning going forward will change, and maybe what role you think FERC and other regulatory authorities have in assisting utilities and power providers with resiliency planning? And then a question from the audience we had that I think is particularly interesting is, how do you value and price resiliency going forward?
Yeah, maybe I could take a crack from the kind of customer standpoint. I think the trend of customers seeking more resilient sources of energy and more self-determination is going to continue. The economics are there. And, a lot of customers back toward their core competencies of speaking to commercial, industrial, governmental customers and away from operating their own on-site generation, that kind of thing. So I think that trend will continue. Customers will continue to seek and pay for that because they see the long-term benefit of going in that direction. Certainly, as you think about those changes out at the ends of the distribution systems, the customers effectively taking more and more load off the grid, that has an upstream impact on Brian's business. How do we plan for central station generation and transmission in that environment? Maybe turn it over to Brian to address that side of the equation.
Yeah, that's an excellent comment, because a lot of these central generating stations can operate at 100% capacity factor, but a lot of the renewable or distributed can't reliably operate at that level constantly. So we're actually looking very closely at, for our facilities, the central generation on unit flexibility. How much can you get the units to turn down? How quickly can you get them to turn down? Because the reality is that we fully support and agree that there has to be more renewables. And we're trying to get into that game even more and more with more and more regulated solar. We just announced another 200 plus megawatts of regulated solar down in Florida. But it's a function of how much sunlight you have, or in the Midwest where we operate plants where there's quite a few wind farms, how often is the wind blowing? So the grid has to be able to react. We continue to look at battery storage as a way to help us in that regard too. But it is probably, if you ask me, the biggest challenge for the central generation over the next 10 years is, as more and more distributed generation, more and more renewables are out there, how we can make sure that the reliable, constant electricity that everybody enjoys is maintained. And that, for our part, means that we have to have more unit flexibility.
Yeah, those are great points. And I just want to add on to the flexibility issue and the ability for the transmission and distribution network to provide flexibility. So for example, in the West, we see that the Western Imbalance Market, operated by the California the California Independent System Operator, incorporates a lot more renewables onto the system, brings down prices for consumers, but also releases some of those wind resources that are in negative pricing zones to access customers that are outside of particular utility footprints. And so it's been a win-win for lower carbon emissions, price electricity to customers. And it's provided that kind of market has opened up flexibility and, essentially an inherent flexibility to a larger transmission grid. Certainly updating the transmission grid and the distribution grid can also provide more flexibility by sharing resources over a larger range, sharing resources between the distribution side and the transmission side of the grid. So we don't want to forget about those solutions as well. At the same time, we do want to think about what reliability means to different customer classes. Some customers would like a high degree of reliability, and some customers really would like to save money through demand response programs. And historically, we've built out the grid to meet a certain reliability standard, but we haven't really justified that reliability standard based off of what customers want. So getting a sense of how customers value reliability is something that we really should look into more and enable customers with the technologies available today to choose the level of reliability they want versus the ability to save energy through demand response programs.
That point about how customers value reliability is very interesting, because you can imagine that that's going to change a great deal right now. I have to say that while all of this was going on and while I was looking at how would utilities of all stripes be affected? How would the water utility be affected? How would the electric power utility be affected? My thoughts turned to my family's house on the Chesapeake Bay, which is on well water, and everything else is electric. And I thought, well, if we put some solar panels up there and get a whole house battery, then if everything goes, we could retreat there and function for a good while. So I think that people's sense of what reliability is and how they achieve it is going to change as a result of this pandemic. Could you guys talk to the opportunities for, I guess, energy storage arrays in this environment? Because one thing that we're seeing right now, although we have a lot of interest in energy storage technologies, although we have a lot of sort of initial investment in research into energy storage technologies, on the one hand, everybody agrees that energy storage is a linchpin to the energy transition. But on the other hand, we haven't moved much beyond, for now, really just using arrays of large batteries to store electricity, to enable that transition for now. And so I think a lot of people in the electric power sector have been looking not just to putting them in one spot, but to starting to create virtual power plants with arrays of batteries, either at people's homes or in the case of Dominion Energy, they're looking at funding electric school buses so that they would then have a virtual energy storage facility at school bus depots around Virginia. So could you guys speak to how you think that we may see changes in the appetite for and opportunities for energy storage?
Yeah, I can take a crack at it because we're doing this in our business now. Start with the premise that stationary energy storage works. Technologically, it works. So the question becomes, is it cost effective? And like all of these technologies, if it's not cost effective, customers generally aren't going to deploy it. You'll get people on the edge that want to do it because it's cool. You'll find people in pockets where, for instance, in California, where there's a lot of subsidies, the SGIP I'm thinking of, for instance, for commercial customers, allows it to be economic to deploy these battery resources in the home and in the office building, in the work environment. But generally, for large-scale deployment of these things, you've got to make an economic case, and we simply can't in this environment. In a lot of places in the country, make that strong economic case for stationary storage in a distributed level. We will make the case. It will happen. Technology, just like solar, technology prices will come down. Delivered energy costs will continue to go up, maybe not because generation rates are high, but because T&D rates are high as we're hardening our grids in our urban centers. So you will have more and more cases where that storage case makes sense. But then you say, do the utilities have the technological tools to see that storage, to operate that storage, to deploy it in an effective, which is a whole kind of different technology overlay that you have to get across this stuff work wholesale in a large scale. It will happen. The question is the time duration of when it's going to happen.
Yeah, Michael, I agree with your characterization there. It lines up with everything that we see on the Duke Energy side. And we also fully recognize that for us to operate is almost a slightly different mindset of operating storage versus generation. One piece I did want to point out is that we've had the good fortune at Duke to have pumped storage hydro, which I call the biggest and somewhat most natural battery you could find, in which you have an upper elevation lake and a lower elevation lake, and you can pump up in the evening or when demand might be low and help your unit, your grid operation during that time, and then deploy the water through the hydro plant when demand is needed. And this was I call an engineering marvel, the two that we have on our system. We've actually even started questioning, is there a way to continue, maybe even expand some of that? And there's a lot of hurdles you have to overcome. But I think the whole point in bringing that up is that storage, we've been doing some level of pumped storage, but getting it down to smaller levels that can be more broadly deployed is certainly something that I think everyone in the industry sees as a reality coming at some point once the economics can be worked out.
Yeah, getting to the economics point, which is very important. You know, certainly when you have customers that are buying batteries because they need them for vehicles, or if they're buying grid-enabled hot water heaters, being able to aggregate those and offer them into, say, the wholesale markets enables grid operators to see them, but also enables these resources to provide some of those storage capabilities more cost effectively, you know, simply because customers have purchased them for other purposes. They also provide these customers with revenues from the wholesale markets, which could help incentivize uptake in these technologies. And certainly PJM has conducted pilot projects where electric vehicles or grid-enabled hot water heaters are allowed to offer in aggregate, on an aggregate basis, and participate in the regulation market with a lot of success. And FERC has in its, in its proceedings, a docket that enables distributed energy resources, including storage resources, to aggregate and offer into the market. So FERC has a role here. They could finalize that role. So I think the economics portion depends a lot on how, as Michael said, grid operators can see and enable these resources to participate, how they can provide, enable those resources to participate, but also enabling storage as a multifunctional asset to participate as a transmission, to participate in a transmission service, to provide ancillary services, energy and capacity services, You know, that's also something that's an important way to enable storage to see the economic case and to scale up appropriately. So that's something that FERC is taking on, and a lot of the compliance filings from the various grid operators are working to ensure storage can provide all the services that it's capable of providing. It's a little less clear on the transmission side. We still need more clarity as to how storage can provide transmission services and receive compensation for that. But these are all issues that are important to resolve.
So we have just about 3 minutes left. And speaking of FERC, which is always a scintillating topic for exactly nobody outside of the energy industry, Chairman Chatterjee has called a technical meeting for July 8th and 9th for FERC to discuss how the electric power sector has fared during COVID-19 and what it should be doing going forward as a result of COVID-19. So could you guys, just to wrap this up, if you could say to him, you know, this is the most important topic that you should discuss at that meeting. Could you guys just in a few sentences pop it out there what you would hope that they put on the table for that meeting? Mike, why don't you go ahead? You look like you're ready.
I was going to just pick up where Jenny left off, and properly incentivizing the deployment of distributed energy resources, particularly storage, in a way that's sensitive to central station generation and all the pricing issues we have there, but also allowing these resources to be deployed and recognized and used by the grid operation teams.
Now, on those same lines, I mean, I think that something that our company, along with many other utilities, is recognizing and planning for and trying to be a leader in is becoming to those lower carbon futures. One of the biggest hurdles that we have is that we also need to have our states come the right regulatory construct to allow us to be able to do this. So in keeping with what both Michael and Jenny have said, I think from our perspective, getting to a greener transition, we would need, you know, the states and the governing bodies to give us some of the mechanisms to help us get there too.
Jenny?
Yeah, I think adding on to that, there are a lot of policies, and the federal government outside of FERC are responsible for promulgating. But FERC can certainly do a lot to ensure that resources like storage, but also energy efficiency, demand response, and renewables can participate equally in the market on a level playing field. And certainly we see that these resources are important for a clean energy transition, but also have, you know, they can play an important role in the potential new normal that we'll see as customers stay at home and work from home, or at least some of them. And transmission is an important part for a lot of different ensuring flexibility, but also it's something key to ensuring reliability as well. So looking at the appropriate cost-effective amount of transmission that could help us share resources between regions and improve reliability at bring on low-cost renewable resources is something that FERC is really in good position to help us promote.
So what I'm hearing from all of you is that, you know, FERC and state governments and participants in the electric power sector should be addressing what's going on with COVID-19, but at the same time, it seems like the focus really is going to remain squarely on continuing along with the energy transition. So with that, thank you guys so much for joining today. I hope this has been a fruitful discussion for all of those who joined us virtually and are listening in. And we look forward to seeing you at future Duke University Energy Initiative webinars and future Duke University Science and Society Initiative webinars and future Duke University Nicholas Institute events. So thank you very, very much.
Bye, everyone. Thank you.
Thank you.
Thank you.